Hi, and welcome to this in-depth tutorial for Gyroflow version 0.3.0 beta. For those of you who are new here, Gyroflow is an open source toolkit for gyro-assisted video stabilization and is particularly suited for FPV footage, where mechanical gimbals can be heavy and impractical, and where traditional stabilization software based on frame motion is unreliable. Gyroflow also removes any lens distortions and works regardless of obstructions or lighting conditions. This software is quite versatile, and other than some caveats, it can work with pretty much any camera you can think of if it's combined with a decent source of motion data. On one end of the spectrum, some cameras can record motion data by themselves. This includes GoPros, Insta360s, and some Sony cameras. Also more recently, I've been collaborating with Runcam to test firmware for their action cameras with gyro logging enabled. So a separate video will be made going into the specifics of processing footage from the Runcam 5, including recommended settings and all that. Gyro data can also be recorded by an external source. On FPV drones, this can be the flight controller black box. It can also be a spare flight controller acting as a dedicated logger, or you can even use more specialized or custom hardware if you want. As a random example, I did some testing using a custom rocket flight computer logging to an SD card. So if you're into electronics or Arduino type stuff, you can fairly easily build your own gyro logger. All of this is flexible, so if you wanted to, you could even use the motion data recorded by GoPro to stabilize the footage from a larger cinema camera. One person mounted a GoPro onto a Panasonic BGH1, and another person used a GoPro as a logger for the FreeFly Wave high-speed camera, which was a whole nother can of worms. But I mean, good news, Gyroflow now supports high-speed footage, so that's kind of cool. I mean, if you really wanted to, you could literally duct tape a drone onto a handheld RED camera and use that for stabilization. It would look a bit silly, I would imagine, but it would technically work. Since the previous alpha release, there has been quite a number of changes to the program. First of all, the user interface has arguably been improved upon. Furthermore, there are also some more automated features which will make the program a lot easier to use. It's not quite one click, but it gets close some of the times. There's also things like audio export, improved smoothing methods including horizon lock, dynamic cropping to make sure that you don't get any black borders within the frame. So a huge thanks to all the testers and the other developers who have helped make all this possible. I have also created a Patreon for people interested in supporting the development of the project. There are some rather exciting stuff planned for the project in the future, such as integrations with video editors and other software. Since I'm a student working on all this in my spare time, I thought a Patreon could help cover licenses and whatnot for future developments. There are also some potentially interesting perks for those of you who are thinking of using this software professionally. Anyhow, now for the tutorial. The most important part with any setup is that the gyro sensor is rigidly connected to the camera since it needs to accurately capture the motion. This means that the camera should be rigidly mounted to a drone when you are using the main flight controller as a gyro source. If you are instead either using internal logging in the camera or a dedicated logger on the camera, it should be soft mounted to prevent high frequency noise from reaching the camera gyro system. Some gyros in cameras are particularly sensitive to drone vibrations, which can mess up the data. In a similar vein, you don't want any real-time stabilization to be present if you want to use gyro stabilization in post, so no optical stabilization or EIS should be enabled on the camera. I have also heard that a camera which has in-body sensor stabilization can still have the sensor wobble around even if the stabilization is disabled. When logging using drone hardware, a black box logging rate of 500 Hz is usually sufficient. In version 4.3 of Betaflight, the log size can be significantly reduced by only logging the gyro and optionally the accelerometer data. In terms of camera recording settings, we want the widest field of view possible to leave the most room for image stabilization. Many sensors used for video cameras have an aspect ratio of 4:3, so if this is the case, see if it's possible to utilize the full sensor by also recording in a 4:3 resolution. Another important thing is frame timing reliability. For stabilization to work well, Gyroflow needs to compute a precise camera orientation for every single frame of interest, so even an offset of a couple of milliseconds can be noticeable in the results. So for the best results, this means no dropped or duplicate frames. Footage with these problems still work in Gyroflow, just not as well. You also don't want any sort of strong jello or rolling shutter artifacts to be present in the footage. There are a few things we need for a program to work correctly. One of them is, of course, the program itself, and since I'm on Windows, I'm using Gyroflow.exe. You can either download this or the relevant executables for Mac or Linux through the link in the video description. We also need an installation of FFmpeg. This is the program that handles some of the file encoding and reading and writing and so on, and there'll also be links to this in the video description. On Windows, you can either install FFmpeg globally such that it's accessible in your terminal, or you can also download and extract the program and then move ffmpeg.exe from the archive over to the same folder that Gyroflow is installed in. And finally, we also need some lens presets. Thanks to all the people who have helped out and contributed with lens presets since the last release, we now have presets for many common cameras. So simply go onto the website, linked in the video description, and download and extract the folder, and once again place it together with the main executable. This will make sure that Gyroflow can find this folder and use the search feature. If everything is installed correctly, you should be able to run the program, and after potentially a bit of loading, if it's the first time, you'll see a window pop up. And if all that is fine, then yeah, we have installed the program. It's not the simplest thing, but I mean, it's not too bad, I guess. So yeah, there we go. If you are lucky, your camera has already been calibrated by a kind somebody, so have a look in the lens presets folder. If there's already a matching lens preset, you can skip this part of the tutorial. If that's not the case, you need to create a new lens preset for your combination of camera, lens, and recording setting. You can use the same preset if the field of view and aspect ratios stay the same. So for instance, you don't need a new preset for each frame rate setting. To calibrate the new camera, select the camera calibration utility from the main launcher. You can now select the size of your calibration pattern, and I'm going to use 14:8 for now, but you can also just use the defaults. We now get the calibration window. And when you first see this and you haven't calibrated a clip before, you want to click on File followed by Calibration Targets. And this will bring up this calibration pattern, which you can use for camera calibration. At this point, you need to take your camera and you need to use the settings which you want to use for your final calibration. You also preferably want to be in a slightly darkened room, such that the calibration target is the only one with a bunch of sharp features. And then you want to take your camera and record your screen while slowly moving around the camera. You want to make sure there's not too much motion blur in the frames if you want to use the automated calibration feature later on. So just slowly move it around and make sure that you get the calibration target seen from a bunch of different angles. Try if it's possible to have the whole calibration path in view the whole time, which will make the automated calibration a lot easier down the line. You want maybe about 60 seconds of sort of footage. You can use more if you want, but if it's continuously moving around, 60 seconds seems to be about fine. When you have captured the calibration clip, just close the calibration targets and we can now begin the calibration procedure. We start by transferring the file over to your computer and click on Open File, and then navigate over to your calibration. Anyways, open the file and we now get the viewer. We can scrub through and see if there are some nice frames. I'll start off by showing you how to do it manually. And in order to do so, just go through and find some nice frames, such as this one. Click on Add Current Frame and it'll try to detect the pattern in this frame. Just go through and maybe add a couple of other ones. I guess this one. And while you're doing so, you can click on Process Loaded Frames and toggle Lens Correction. And we should see that over time, the image becomes more and more calibrated. The lines become more and more linear and so on. You want maybe about 20 frames or so to get a good calibration. So just go through and do that a whole bunch of times. If one of the frames gives an error or if it looks totally weird, just remove the last frame and try again. If you want to do it automatically, which is a lot easier, you click on, once again, I'm just going to reload the file, and you can click on File and Start Auto Calibration. This works particularly well if there's not too much motion blur, so most of the frames in your source video are usable for calibration. And as you can see here, it goes through and picks a whole bunch of frames from the video, about 50. Yeah. So let's just wait a couple of seconds for it to finish up. There we go, and we see that we have 50 frames, and out of these we have 47 good frames. And let's once again click on toggle lens correction, and we see that the calibration has worked out quite nicely. So if you have a nice calibration footage, you can use the auto calibration. But if the majority of the calibration clip is not suited as calibration frames, you can do it manually instead. When you have done this, you need to, on the right hand side, fill in a bunch of details. So you'll fill in the camera name, the camera make, and also the lens. Some of these are not required, of course. Recording setting, I don't know, 720p or something at 16:9. And notes, if you had some notes you want to fill in for future people to read, just fill it in here. And of course, your name. Finally, click on Export Preset File, and you can go to the camera presets folder and just save it somewhere where you think it'll fit in nicely, I guess. And yeah, just save it. It's now time for the section about video stabilization. For the sake of going into a bit more detail, I will cover what many of these settings do, but note that for most of them you can just leave them alone and use the defaults. I will assume that you at this point have both a video file and a gyro source. These can be the same file, or it can be two separate ones. If you are using an external logger such as a drone flight controller, I recommend attempting to start or stop recording within about 5 seconds of each other. Alternatively, you can also time it. For instance, you can start a video and wait like 10 seconds and then start recording. It doesn't have to be precise, just a rough offset we can work with. So now click on video stabilization. So we now need to basically open up the various files we need. We need the video file, we need the lens preset, and we need the gyro source. So in this case, I'm going to use an example from a Runcam. And as previously mentioned, I'm going to make a separate video about the Runcam 5 since there are some specific settings you need to select to get the optimal results. So I'm just going to use this one. This is Runcam 5. And as you can tell, it automatically detected the gyro log. If you're using a black box file, try to just to keep things organized and make sure that the black box file is named the same as the video file, and then it should automatically detect the matching ones. Otherwise, if you're using either an Insta360 or a GoPro camera, you can just use them as is. It'll try to detect the file itself. We now need a preset, and this recording was done using the 4K-XV recording preset. So I'm just going to, as you can tell, there's a search feature. This one. So this is a bit of a special preset. It's stretched. You can also click on this button to open the file browser and navigate for the preset. So the rotate video is if you have your video in portrait or something crazy, you can rotate it. Then we have the gyro log type. It will try to automatically detect the log type, but if not, you can go through and select one of these types. Something I've noticed that Sony gyro is not in here. And that's because at this point, it's not integrated in this program itself. You need a separate program. And if you want info about that, there's a link to a Discord server in the video description. And there's also the gyro source variant. And the reason for this is that different setups using the same type of gyro log can have different orientations. The camera to gyro angle is if you're using something like a black box log. So if your camera is tilted to some upwards angle, you need to put in the angle at this point. And also I have added tooltips for most of the options. So just hover over anything you're wondering about. And then we have the load pass filter. So we can start off by trying to disable this. So -1. And let's try to disable it. And there's now this button where we can plot the gyro and do some analysis. So over on the right-hand side, people who have done black box logging and so on will be kind of familiar with this. We have a Fourier transform on the bottom, which shows basically the intensity of the frequencies at different frequencies. Down in the low end, we have some low frequencies, and these are the actual movements of the camera. And over on the right-hand side, over at around 200 hertz, we have some fairly strong vibrations. These are caused by things like the motor and so on. And you can also see these vibrations over in the gyro track. So if we zoom in, we see a whole bunch of high frequency vibrations. And these are not that great. You can imagine if we try to use this information for video stabilization, it'll look rather messy to say the least. So we want to only have the real movements down at the bottom. So let's set this filter to something like 60. And this will filter our wave frequencies above 60 hertz. So if we once again analyze, we can see that, yeah, all the frequencies over at around 200 hertz, they have now been filtered away, and we only get, I mean, it's a bit better than what we had before, right? There's still a bit of noise, but this is fine. Now that's all for the input tab. And the nice thing is that most of it is automated. So you can, in most cases, just open the video file, open the gyro, or open the presets, and everything else has been filled in for you. And yeah, let's now go over to the synchronization. We need to accurately synchronize the video frames and the gyro log. And there's now a feature to do so automatically. So in many cases, you can actually simply click on the attempt auto sync and it'll try to do some analysis. Something of note is that all the logging and so on, or all the information of what's happening in the background, these can be found in the command line. So if you have some space in the window, it can be nice to have this command line open just to see what's happening in the background. The thing about autosync is that it usually takes longer than if you were doing it manually, but it usually gives slightly better results. And this also opens up the possibility of batch processing in the future, since you don't need any manual interaction. There can be cases where autosync doesn't work that well. This is especially if you have really tricky footage with a whole bunch of motion blur and so on. But I found that in many cases it works fairly well. But yeah. So this is what you see when the auto calibration has finished. You get two main plots. One of them, this one shows how the calculated delays are with relation to each other. And you can see there's a somewhat of a downward trend slightly. So it said something like, okay, so this seems like the good way to sync most of them. And as we can see in this other plot, which can be a bit overwhelming, but we can see that the movements between the gyro and the video, they match up quite nicely. So if we now close this and go back to the main window, we can see that a few points have been added, and these are our sync points. You can delete these if you think that they don't work as well, or you can also add a new one. You can add new ones by going to the right place in the video and then click on add sync, or you can input your frame or your timestamp at this point and add a sync at the specified timestamp. Once again, for many of the other settings, the most important one is actually the first one, the initial offset. If you're using the gyro recorded in the camera, you can leave this at 0. Also, if you started gyro recording and video recording within a few seconds of each other, you can also leave this at 0. Otherwise, you can either increase the surge size or you can change the offset. And you can once again look at the tooltips and they should describe what you need to do. So we can now see that, yeah, after it has computed the syncs, we can now see what the stabilized footage looks like. There are some sliders to mess around with to zoom in and out. Now the next thing that's
kind of exciting is the stabilization tab. Previously, there was only one stabilization method, but now a number of other ones have been added to the mix. And now let's take a look at the export tab. Many of the options here are quite self-explanatory. Something I've noticed that if you recorded your video using a 4:3 aspect ratio using a fisheye lens, such as using a random action camera, I recommend exporting to a resolution that is 16:9. The reason for this is that during the undistortion process, the image is essentially stretched more horizontally. So the result is that if you crop to a 16:9 aspect ratio, you get more of the field of view in view, essentially. So let's just, for the sake of this tutorial, do 1280 by 720. And now we have the adaptive zoom settings. If adaptive zoom is enabled, the first slider can be used to specify how it acts. If you wanted to zoom in and out really quickly, you can decrease the smoothing window. And if you alternatively wanted to zoom in and out really slowly, you can increase it until the point where it's fixed, which is essentially just a fixed cropping at a point at which there's no black edges visible at any point in the video. If adaptive zoom is disabled, you can use this slider, the zoom factor, to decide once again how much zoom in and out it is. And in this case, the zoom factor is actually the same as the FOV scale down below. So if you for some reason think that this is a reasonable zoom level, you can set the slider to the same value, and the result will be about this view, depending on the resolution, of course. And then we have the encoding setting. If you're using an NVIDIA graphics card, you can try using the NVENC encoding, which is a bit faster. And also, if you're on AMD, there's the AMF one. Now we have a bunch of other options. These are quite self-explanatory. If you want to speed up the rendering, you should disable the preview, but let's just leave it on for now. We have the bitrate, and then there's the background color. I just show a couple of fun examples of what this does. And then we have the hyperlapse options. Hyperlapse is essentially a stabilized time lapse. So the first one specifies how much the speed is increased by. So yeah, what it says in the speed multiplier. And the second one can be used to fake the motion blur to make it look smoother. So let's say you want to speed the footage up 60 times, but at the same time also getting the equivalent of a 180-degree shutter. Then you would set the 60 times as the speed multiplier and 30 as the number of blended frames. And I'll just show you some examples now. When you have a nice stabilized video and a sync in the user interface, I do recommend clicking on this Export Gyroflow Data button. So I'm just going to do that now. What this will do is it'll save the synchronized gyro data as well as all the lens parameters and settings and so on. And this can either be read by Gyroflow in the future if you want to process the same clip once again, or in the future when there are some video and editor integrations, you'll be able to import this file together with the footage to apply the stabilization there. So now let's try to export our clip. Let's just enable adaptive zoom and let's set it to the default, and this should work about, right? And let's set this back to 1 such that we don't get any black edges. And let's export the footage. And I don't know, let's just say random clip. It'll take a couple of seconds for it to do some computation, and afterwards you should see that the preview window has the render preview. So yeah, that's pretty much it. You can leave many of the settings alone to their defaults and it'll work. But I just want to go over, what the different settings do. And when the render is done, if you have the audio export enabled, it'll also take a couple of extra seconds to embed the audio in the video. And yeah, that's about it. I think it should be rendered at this point. So let's take a look at the results. Yeah, nice. We now get a stabilized result. Since we saved the Gyroflow data file, we can click once again open a file. And if we select the same one as we did previously, you'll see that it asks for if you want to load the associated Gyroflow data file. Let's just say yes. And it might take a couple of seconds since it needs to do some of the processing once again. But when that's done, you will see that we get the already synchronized and stabilized footage available. So you can then go back in and tweak the smoothing settings and once again export to a different file if you want to do so. So the nice thing here is that you only need to synchronize each clip once. And in the future, when there's some batch processing added, you'll also be able to just batch process a whole bunch of clips and just go back in and export the way you like. And let's also quickly see what it's like if you are not using internal logging, but if you're using something like the black box gyro log. So this is recorded using a DJI air unit, I believe. And let's just DJI air unit. There we go. And as you can tell, if it detected the gyro log as well, since it's the same name. This is using a black box CSV file. And by the way, I recommend exporting to the CSV file instead of using the raw BBL files, since sometimes, especially if you're on INAV or something like that, the raw black box file cannot be read. And the camera angle was about, I think it was 11 degrees. And here we can just set the rest to the defaults. Let's click on attempt sync. And once again, wait a few seconds. This is a lot faster since the resolution of the DJI Air unit is not 4K, so it only takes a few seconds to do. And here we go. We now have a nice sync. And it's zoomed out quite a bit. And as you can tell, we get a nice stabilized clip. And once again, go to the export. We want to save the Gyroflow file for future processing. And once again, just put the settings you want for export, and you've got a stabilized clip.
What I showed should work for the majority of clips, but if it didn't work, here are some tips and tricks. First of all, make sure that the settings in the input tab are correct. Make sure that you're using the correct log file, the correct camera preset, and gyro log settings. Different formats have different gyro orientations, so this is really important. Secondly, if you're observing jitter in the result, this is likely due to either bad sync or excessive gyro noise. You can try to start off by adding syncs to just the part of the video you're interested in exporting. This decreases the effect of any dropped frames on the final result, since the timing issues aren't as prominent. If no amount of syncing seems to help, it may be an issue with the gyro. Either the gyro logger isn't rigidly connected to a camera, or maybe high-frequency vibrations are present. If vibrations are a problem, you can start off by trying to decrease the low-pass filter cutoff in the input tab. If this still doesn't work, you can try to further mechanically dampen the system to isolate the higher frequencies. You can use things like 3D printed mounts and so on, and you can have a look online and see if there are options. Cinelifter people, they also have their own special stuff. I don't even know. Secondly, you can try to shake the camera at the beginning and the end of the recording and use these points for synchronization. The best points for sync usually have some rotational motion, but not too much motion blur, parallax, or jello. If you at some point in the video see some prop wash or jitter, you can try to use that point for synchronization, since the fairly high frequency movements work fairly well to match the gyro and the video. After adding the points, remember to click on the recompute button to use the newly added points for the analysis. Also, as a general rule of thumb, the program is unable to handle a crazy amount of jello, so I would still recommend ND filters for bright daylight footage. Try to make the recording as smooth as possible to decrease motion blur and also the amount of cropping required in the output. If you are still having issues, the best place to ask is in the Discord server linked in the video description. That's also where most of the talk about testing and development happens, so I will be looking out for any problems or questions. Some Patreon tiers also get a priority tech support. Basically, I'll try replying to PMs as soon as possible if I'm available. But I do want to stress that if you're having issues, I'll still try to help even if you're not a Patreon supporter. Technical issues or bugs can also be reported through GitHub if you know it hasn't been solved in the codebase yet. At some point, I'll update the Gyroflow website with even more tips and tricks, so it's worth having a look there if something still doesn't work. Anyways, that's all for this tutorial. It was really cool to see people try out the previous alpha version on a bunch of crazy hardware, so I'm looking forward to see what people can do with this beta release. Feel free to use #Gyroflow if you're into that sort of stuff, and I'll make sure to check it out. Anyways, bye!